When you work truth table problems, the first thing you need to do is memorize the truth tables for and or statements. It might be helpful to think of a capital A to help you remember that the caret symbol here means and. It is similar to intersection, which is this symbol for sets. And statements are only true if both parts are true. Hence, their truth table is going to look like this. P could be true, Q could be true, and the AND statement will be true. P might be true, Q might be false, which is going to make the AND statement false. P could be false, Q could be true, which would make the AND statement false. And Q could be false, and P could be false, which would make the AND statement false. I didn't quite leave myself enough room. So you can see the only time an AND statement is true is if both pieces of it are true. And that might be easier to remember than doing the truth table. And the truth table comes from all the possibilities. If you've got two statements, then there are four things that can happen. Both are true, both are false. The first one's true, the second one's false, or the second one is true and the first one is false. Now, or statements are similar to unions in set theory. They're true if either part is true, or another way to think of that is the only time they're false is if both parts are false. So if we do the truth table for an or statement, the possibilities are that the first statement is true, the second statement is true, then the or statement is going to be true. The first statement could be true, the second statement false, but the or is still going to be true. The first statement false, the second statement true, and the or is still going to be true because if any part, either the P or the Q is true, the or is true. And if they're both false, then the whole statement is false. So let's look at some examples. Let's suppose that P is actually a false statement and that Q is a true statement. Then we want to find the truth value of P or Q. So what we would have is an or statement where P is false and Q is true. So we would have false, true, and with an or statement we just said they are true if either part is true. So P or Q would be a true statement in this case. If one of your pieces is false and the other part is true and you connect them with an or, then the whole thing is true. Not Q is the opposite of whatever Q is, and in this example we said that Q was a true statement, so not Q would be a false statement. P and not Q, okay, P it tells us is false, so we have a false statement, and not Q, we just said not Q was false. So we have an and statement with false and false, therefore it's going to be false because we said an and statement was false if either piece of it was false. So let's make up another one. How about not P and Q? So not P, it says originally P is a false statement, so not P would be true. And Q is a true statement, so we would have true and true. And statements are only true if both pieces are true, so not P and Q in this instance would be a true statement. Now let's look at not P or Q. So not P, originally P is false, so not P would be true. And Q was true, so we got true or true. So that would be a true statement. How about P or not Q? Well, P is false, so that would be a false statement. And Q is originally a true statement, so not Q would be false. So we would have false or false. And the only time an or statement is false is if both pieces are false, so that would be a false statement.